Good day everyone. So here we have a problem for the chapter 4, the relative equilibrium of liquids. So in this problem, we have a closed horizontal cylindrical tank which is filled with gasoline. So the givens in the problem would be diameter, which is diameter of the horizontal cylindrical tank, 1.5 meters, times the length, which is 4 meters, acceleration of 3 meters per second squared, and specific gravity of the gasoline, which is 0.82. So here we have a figure of the closed horizontal cylindrical tank, which goes to the left, accelerates to the left. So since the horizontal cylindrical tank is closed and is filled with gasoline, so we will have an imaginary fluid level of gasoline as it accelerates to the left. So the measurement for the height of the imaginary fluid level would be y. So solving for the y, we will have first solve for the theta, which is equal to tangent raised to -1 times acceleration over gravity. So we will have 17 degrees. And solving for the y would be the length times tangent theta. So we will have 1.22 meters for the y. So after that, we solve for the total force acting on the rear wall. So the rear wall would be here. So solving that would be specific weight times height times area. So 0.82 times 9.81, specific gravity times the gravity would be the specific weight times 1.22, which is the y, plus 0.75, which is the half of the diameter. So height would be from half of the diameter up to here. So 1.22 times 0.75 meters times the area, which is pi d squared over 4. So we will get an answer of 28 kilonewton. Since we can just simply cancel the meter cube here, the meters here, and the meter squared here. So that would be the answer for the total force on the rear wall. So solving for the total force acting on the front wall, so the front wall would be from here. So using the same equation, so specific weight times height times the area. Specific weight would be equal to specific gravity times gravity times the height in the front wall, which is from the center of the diameter to here. So it will be the radius times the area, which is pi d squared over 4. So we will have an answer of 10.66 kilonewton. Since we can just simply cancel the meter cube here, meters here, and the meter squared here. And then solving for the accelerating force on the liquid mass, so we will use the formula force equals to mass times acceleration, where mass can be equal to density of the gasoline times the volume, which the gasoline or the density of the gasoline can also be equal to the specific gravity of the gasoline times the density of the water. So we will come up with 0.82, which is the specific gravity of the gasoline, times the density of the water, which is 1000, times the volume. So volume would be area times the length. So the area, which is pi d squared over 4, times the length, which is 4 meters, times to the acceleration, which is 3 meters per second squared. So solving that, we will get 17.39 kilonewton. Since we can just simply cancel the meter cube here, the meter squared here, and the meters here. So we will be left with kilogram times meter over second squared, which is equal to kilonewton.